Good day everyone, you're welcome to my YouTube channel, and today we'll be treating the 40 likely JAMB Physics questions that you are going to see in your JAMB exam. We have done the biology version of this particular video, so I have brought a seasoned physics tutor to take you guys on these 40 likely JAMB Physics questions from my tutorial. So let's get right into the video.
Question 3. What is the reading of the micrometer screw gauge? A. 3.5 millimeters, B. 3.67 millimeters, C. 3.70 millimeters, D. 4.01 millimeters. Now, if you come across a question like this, all you just have to do is what? Look at, you have your micrometer screw gauge. Look at the first scale and the second scale. Now, take the readings. You have 0, 0.5, 1, 1.5, 2, 2.5, 3, and 3.5. That is for your first scale. Your first scale is what? 3.5. The reading of your first scale is what? 3.5. Write it somewhere. 3.5 millimeters. Write it somewhere. That is 3.5 millimeters. That is the reading of the first scale. Now take the reading of the second scale. Now look at this. How do we take the reading of the second scale? Look at this horizontal line from your first scale here. Now look at the point whereby it coincides with the what? The mark of your what? Second scale. Now look at this. Now we have 10, 11, 12, 13, 14, 15, 16, 17. Now the point 17. That is where the horizontal line meets. I get it now. That is the point whereby the main scale and the what? The smaller scale where they coincide, where they meet. I get it now. So that is 17 at point 17. So you are just going to do it for you are going to do something to questions like this. The readings of your small scale, you divided by 100. Always divide by 100. So you have 17. You have 17 divided by 100, which is what? 0.17 millimeters. Are you getting now? 0.17 millimeters. What you have to do now is what? Add your 0.17 millimeters, add it to 3.5, which is the reading from your main scale. So to give us 0.17 millimeters, that will give us what? 3.67 millimeters. 3.67 millimeters. So for a question like this is how you solve them. Option B is the right answer to this question. 3.67 millimeters. Now question 4. The velocity v of a particle in a time of t is given by the equation v is equals to 10 plus 2t. Find the instantaneous acceleration after 5 seconds. Find the instantaneous acceleration after 5 seconds. All you have to do here is now you are going to apply your differentiation to this. Are you getting me now? That means you are going to look for acceleration is changing velocity with time, right? So changing velocity with time here won't be the normal v2 minus v1 over t2 minus t1 that you guys know. So you are going to apply your what? Your differentiation here. So now acceleration is equals to what? Change in velocity over change in time. Change in velocity over what? Change in time. So now your change in velocity over change in time here, that means you are looking for what? You are changing v irrespective of t. I get you now. So for acceleration is change in velocity over change in time. What you are going to do here is use your differentiation. I get you now. Your differentiation, that is we have our v to be what? 10 plus 2t squared, right? 10 plus 2t squared. So now this is a constant. I get you now. So the 10 is out because it's a constant 10. Does not have any letter. I get you now. So if it does not apply, if it does not have any letter from our differentiation, we know it is equals to 0. So now, here we have our 2 here. I get me now, and the formula is actually ax. I get it now. N minus 1. This is our a. Our a here is 2. T is x here. Our n here is also 2. So what you are going to do here is what? Now multiply this our what? Bring this n here. This n that we have here. You need to multiply your a, which is your 2, that is 2 times 2 t 2 minus 1, that is 4t raised to power 1, that is 4t. Are you getting me now? So acceleration here is equals to what? 4t. A is equals to what? 4t. So that means your a is equals to what? 4 times. What is the value of our t here? The value of our t is what? 5 seconds. Is what? 5 seconds. So you now have 4 times 5, which is what? E is equals to what? 20 meter per second squared. That is the value of our what? Acceleration in questions like this. All you just have to do is what? Use your differentiation, get your change in v with what? T. And the questions like this, you apply what? Differentiation. I get me now. So you use a little bit of differentiation. That's just the basics in differentiation, the first two in differentiation. So you differentiate this, I get me now. You differentiate v in respect to what? T. With respect to t, you differentiate v. Then from there, you are good to go. Question 5. A machine gun with a mass of 5 kg fires 50-gram bullets at a speed of 100 meters per second. The recoil speed of the machine is A. 2 meters per second, B. 3 meters per second, C. 1 meter per second, D. 8 meters per second. Now look at this. All you're just going to do is write your parameters out. That's the first step. Write your parameters out. The mass of the gun, let's say mg, mass of the gun is what? 5 kilogram. Now let's write the other parameter. Fires 50-gram bullet, that is mass of the bullet. Mass of the bullet. So let's say mb is equals to what? 50 gram. mb is equals to what? 50 gram. So you convert it to what? Kilogram, which is what? Divided by 1000. So it gives us what? 0.05 kilogram. That is the mass of the bullet in kilogram. We now have speed of the bullet. That is also the velocity mv of let's just say v, velocity of the bullet. Velocity of the bullet is what? 100 meter per second. The recoil speed of the machine is, whenever you say recoil, that means rebound. I get me now. What's it called? Let me put it this way: opposition to what? A force. If it's forward, then the recoil, that means a backward force. Let me put it that way: a backward motion. I get me now. That is your recoil. So if you want to get your recoil velocity, in this case, now you can remember the laws of your conservation of momentum. States that the total momentum, I get it now, the total momentum, maybe momentum of the first body and momentum of the second body, that's the total momentum. When they split, I get it now, when they separate, it is equals to what? 0. So definitely, yeah, we are going to say M, let's take one for our gun and bullets, MA and V, okay, sorry, MB plus VB plus MG plus what? Multiplied by VG, which is equals to what? 0. Is equals to what? 0. That is the momentum of our bullets plus the momentum of our gun is equals to what? 0. Is equals to 0. So from here you can what? Take this to the other side. You now have MB VB is equals to minus MGVG. So what you have to do here is what? Now what's our MB? Our MB is what? Mass of the bullet. Mass of the bullet, that is 0.05 kilogram. I get it now. Let's remove the kilogram for now. So multiply by VB, which is what? 100 meter per second. 100 meter per second is equals to, now mg, which is mass of the gun, is 5, right? Multiplied by vg, which is velocity of the gun. Now that's what we have to look for. That is the recoil velocity of the gun. If you shoot a gun now, there's this backward reaction you have. That is the recoil velocity. So let's look at the velocity, recoil velocity. Let's say that's what? Vg. So 100 multiplied by 0.005 will give us what? 5. Then we have minus 5 Vg, right? Then divided by minus 5. So we have the velocity of the gun, the recoil velocity of the gun is equals to what? Minus 1 meter per second. Now if you look at our options, we have 2, we have 3, we have 1, we have 8. Now this minus here is just telling us that is what a backward motion. I get me, is an opposition force. It's an opposition force. That is why you are trying to tell, okay, it is not moving in the direction of what's it called, the bullet. I get him now. It is against, I get him now. It's moving against the direction of the movement of the bullet. So we're having, the answer here is what? C, 1 meter per second. That is the answer to this. Option C is the answer to this. Question 6. A 5-gram block is released from rest on a smooth plane inclined at an angle of 30 degrees to the horizontal. What is its acceleration? A, 5 meters per second square. B, 3 meters per second square. C, 2 meters per second square. D, 6 meters per second square. Now, if you come across a question like this is what you have to do. Write out your parameters first. A 5-kilogram block, that is mass of the block. I get to know the mass here is 5 kilogram. Now, from rest on a smooth plane incline. Now, let's say the theta here, which is our angle, is 30 degrees to the horizontal. I get him now. So that means the block is inclined to the horizontal. I get him now. Inclined to the horizontal. So that is the angle, 30 degrees. Now, what is its acceleration? You know, our force is what? Mass times acceleration. You get me now? So mass times acceleration, that is our force. Now, we're having inclination here. I get me now? We're having inclination here. Definitely, our force also. We can also have force here. You know, force is equals to mg sine theta. Why am I using sine theta? It is inclined to the horizontal. I get him now. That means it is having a vertical component. I get him now. It's having a vertical component. That is F equals to mg sine theta. Now, what you just have to do now is equate our force to each other. That is our ME. You know, our force is equals to mass times acceleration, and our force is equals to what? Mg sine theta. I get him now. When we ask you for the vertical component of the force, I get him now. Is what? Mg sine theta. Then definitely you can say MA is equals to what? Mg sine theta. Then from here, M we cancel M. We have A is equals to what? G sine theta. Now from here, A is equals to what? What's our G? Acceleration due to gravity. Unless stated otherwise, it is 10. 10 sine 30. Then that's what? 10 sine 30. That's 1 over 2 times 1 over 2. Then A is equals to what? 5 meters per second square. That is option A. That is the answer here. Question 7. A simple pendulum 0.6 meter long has a period of 1.5 seconds. What is the period of a similar pendulum 0.5 meter long in the same location? A, 1.6 seconds. B, 1.2 seconds. C, 1.3 seconds. D, 2.0 seconds. Now, when it comes to our period in simple harmonic motion, we have period is equals to 2 pi square root of what? L over G. That means our period is directly proportional to the square root of our length. That means period is directly proportional to square root of what? Our length. Then you can say T1 over square root of what? L1 is equals to T2 over what? Square root of what? L2. So from here, input the values of our T1, T2, and L1 and L2 if given. So let's look at our parameters now. Now the parameters, we have T, which is the period. T1 was given to be what? 1.5 seconds. Now we now have our L1 to be what? 0.6 meters. Then we now have L2 to be what? 0.4 meters. Then T2 we ask you for the period when the length is what? 0.4 meters. Now using this formula, we can make T2 the subject of formula. We make subject of formula, that is T2 is equals to what? T1 times square root of what? L2 over what? L1, square root of L1. Then our T2 is now equals to what? T1 here is what? 1.5 seconds times 0. Our L2 is 0.4 over square root of what? 0.6. square root of 0.6. Alright, then from here we can write this as T2 is equals to 1.5 square root of 0.4 over square root of what? 0.6. 2 here, you can say 2 here 2, 2 here 3. So we now have T2 is equals to what? 1.5 times square root of what? 2 over 3. Then that gives us T2 is equals to what? 1.2 seconds. If you calculate the square root of 2 over 3 multiplied by 1.5, which is our what? Our T1, it gives us what? 1.2 seconds. Even from here, T is directly proportional to L. That means if there is an increase in period, there will be a corresponding what? Increase in length also. If it's inversely proportional, that means increase in period will lead to a decrease in length. Increase in period will lead to a decrease in length. That means when it comes to inversely proportional, definitely if there is a decrease, we are having directly proportional here. If there is a decrease in period, there will be a decrease in length also. I get it now. So here we had 0.6 meter long. That was the first length. It was, and the period was 1.5. Now they reduced it. I get it 0.4 meters. I get it now. They reduced the length. Now the period reduced to what? 1.2 seconds. I get it now. These are the ways you you shorten your options when it comes to JAMB. I get it now. So if you look at the options, I get it now. The one that is actually smaller compared to the first options you have. You know you have 1.5. Definitely your answer will not be what? Greater. I get it now. Greater than 1.5. You have options that are what? Less than 1.5. That will be your answer. I get it now. So those are the ways you work smart when you answer JAMB questions. The answer here is 1.2 seconds. The period is what? 1.2 seconds. Question 8. A body is projected from the Earth's surface with the intention it escape from the Earth's gravitational field. What is the minimum escape velocity of the body? Now, this is under gravitational field. We have to look for what? Escape velocity. And to calculate for that, escape velocity is equals to what? Square root of what? 2g_r. Now, our g is what? Acceleration due to gravity, which is 10 meters per second square. Our r is what? 6.4 times 10 raised to the power 6 meters. That is the radius of the Earth. It is constant. So we have v is equals to square root of 2 times 10 times 6.4 times 10 raised to the power 6. So this will give us v is equals to 11,314 meter per second. So by the time you calculate for this, it's giving us 11,314 meter per second. So whenever I come across a question like this, just look at in the question we're not giving radius of the Earth. It's a constant, so you have to know that the radius of the Earth is 6.4 times 10 raised to the power 6 meters, while acceleration due to gravity is 10 meters per second. So by the time you multiply this 2 times 10 times 6.4 times 10 raised to the power 6, then you look for the square root, it's giving 11,314 meter per second. That is the velocity. Then if you want to convert this to kilometer per second, you divide by what? 1,000. If it's not in meter per if it's not in meter per second, and you have your answer in kilometer per second, you what? Divide by 1,000. That is what? 11.314 kilometer per second. That is the answer to this question. Question 9. A mirror of weight 75 Newton is hung by a cord from a hook on the wall. If the cord makes an angle of 30 degrees with the horizontal, the tension of the cord is. Now, to calculate for tension, now you have to call the relationship between your weight and the tension. For weight, we have weight is equals to what? T sine theta. I get it now. T sine theta. So from here we can say, okay, weight is equals to T sine theta. Then you divide. What do we want to get? We want to get the tension, right? Divide both sides by what? Sine theta, right? So T is equals to what? Weight divided by what? Sine theta. Then T is equals to what? 75 divided by sine 30. Then T is equals to what? 75 divided by 0.5, which will give us what? 150 Newton. So that is the tension. So the answer is option A, 150 Newton. Question 10. A motorcycle of mass 100 kg moves around in a circle of radius 10 meter with a velocity of 5 meter per second. Find the coefficient of friction between the road and the tire. A, we have 0.4, B 0.1, C 0.3, D 0.5. Now if you look at this now, the motion is in a circular path. So the force is to be what? Centripetal force, that is denoted as mv squared over r. That is what? Centripetal force, right? Mv squared over r. That means we are looking for the centripetal force first. Now, what is our mass? Our mass is what? 100 from the question. 100. What is velocity? Velocity is what? 5. So that's 5 squared over. Now, what is the radius? The radius is what? 10 meters. So 10 meters. So we have F equals to what? 100 times 25 over 10. 0 cancels 0. So we have F equals to 10 times 25, which is what? 250 Newton. That is the centripetal force. Now, how do we get coefficient of friction? You know, we said coefficient of, our frictional force. When it comes to frictional force, we said frictional force is equal to what's it called? Coefficient of friction times of normal reaction. So in this case now, we can say our force now, coefficient of friction is equal to what? F over R. That is force over normal reaction. And to get our normal reaction, how do we get normal reaction? Is that when it is inclined, we say it is mg sin theta, or we say R is equals to what? Mg. So get our R first. Then what is our R? R is equals to 100 times the mass, right? The mass is what? 100 times gravity, which is 10. So our normal reaction is what? 1000 Newton. So we take their ratios. So coefficient of friction is what? F over R. That is, F is what? 250 over what? 1000. That is 1 over 4, which is equals to what? 0.25. That is option D, is 0.25. That is option D, is 0.25. So that is the right answer to that. Question 11. A body rolls down a slope from a height of 100 meter. Its velocity at the foot of the slope 20 meter per second. What percentage of its initial potential energy is converted to kinetic energy? So this one, you are just potential energy is being converted to what? Kinetic energy. So we have to for the what? Percentage of the what? Potential energy that was converted to what? Kinetic energy. So this is how we do it. You have to calculate your what? Your potential energy, calculate the what? Kinetic energy. So let's do that. Potential energy is equals to what? mgh, right? Mass times gravity times height. If you look at this, we have our potential energy to what? Mass. We don't have any mass here, okay? Let's just say we don't have the mass, and we have gravity to the what? 10, and we have the height to the what? 100. So we can input that here. So that's 1000 m. That's in terms of what? Mass. 1000 m. So let's do that for our kinetic energy also, which is 1 over 2 mv squared. So kinetic energy is equals to 1 over 2 times m times velocity. What's the velocity here? 20. So 20 squared. So kinetic energy is equals to 1 over 2 times m times 400. So 2 here, 1, 2 here, 200. So we have kinetic energy is equals to what? 200 m. So what we have to do now is just look for their percentage of conversion. So how do we do that? Now, to do that, percentage of conversion is equals to energy converted over initial potential energy times 100%. Energy or percentage of conversion is equals to what? Energy converted, that is the what? The kinetic energy. Are you getting me now? You know, potential was converted to kinetic energy. So the kinetic energy here, that's the energy converted. So that's 200 m. So 200 m. It was in terms of what? Mass. We're not given the mass. So and initial potential energy was what? 1000 over 1000 m times what? 100%. So m will cancel m. 200 here 1, 200 5. So we have 5 here 1, 5 here 20. So we have percentage is equals to what? 20%. That was the percentage of potential energy that was converted to what? Kinetic energy. So we have 20%. That is option D, 20%. All we just have to do is what? Look for the percentage of what's it called? Look for your kinetic energy, look for your potential energy, then kinetic over potential multiplied by 100, because what's it called? Kinetic was the energy we converted to. I get it now. The energy we converted to was kinetic energy. So our kinetic energy was 200 m in terms of mass, 200 m, and our potential energy was 1000. So 200 over 1000 times 100%. That's 200 here 1, 200 in 1000 is 5. So 100 divided by 5 will give us 20. So we have 20%. That is the percentage of potential energy that was converted towards kinetic energy. That means 80% was lost to the environment. So we have 20% of potential energy that was converted towards kinetic energy. Question 12. A piece of rubber 10 cm long stretches 6 mm when a load of 100 Newton is moved from it. What is the strain? A is 0.06 cm, B is 0.15 cm, C 1.2 cm, D is 0.47 cm. So this is what you have to do here. Our strain is what? Strain, tensile strain is what? Extension over length, original length. So you have to look for what's our length here. Our length is what? 10 cm. So length is what? 10 cm. While the extension, it says stretches 6 mm. So that is the extension. So we have to convert millimeter to centimeter. You have to what? Divide by 10. Whenever you want to convert what? Millimeter to centimeter, divide by 10. So in order to convert this to what? Centimeter, we divide by 10. So to give us extension is equal to 0.6 centimeter. So let's go back to our formula. Strain is equals to what's extension? Is 0.6 over 10, which is equal to 0.06 centimeter. So this is the answer. So that's option A, 0.06 centimeter. That is for what? Tensile stress, which is what? Extension over length. Question 13. An elastic material has a length of 36 centimeter when a load of 40 Newton is hung on it, and a length of 45 centimeter when a load of 60 Newton is hung on it. The original length of the string is A 15 centimeter, B 12 centimeter, C 17 centimeter, D 18 centimeter. Now if you want to solve this, you know, when it comes to extension and what's it called, elasticity, we have Hooke's law. It states that force is directly proportional to what? Extension. That means F is equals to what? KE. Then from there we know our elastic constant is equals to F over E. So in this case you can say F1 over E1 equals to what? F2 over E2. Now if you want to get extension, how do you get extension? That means new length, you subtract your new length, that is new length minus original length. That is final minus original, final minus initial. So this will give us F1 equals to what? Our new length, that is, let's say L1 minus L0 is equals to what? F2, L2 minus what? L0. That's how we get what? The extension. So if you look at the question, our length L1 is what? 36. L1 is 36. Let's write them out. L1 is equals to what? 36 centimeter. And F1 is what? 40 Newton. So 40 Newton. And L2 is what? 45 centimeter. And F2 is what? F2 is what? 60 Newton. So from there we are good to go. We can say F1 is what? 40. Then we put the values into the what? Formula. So L1 is what? 36 minus L0, which is the original length, and there we have 60 over what? 45 minus what? L0. Then we are good to go. We can what? Cross multiply. You can say 40 open bracket 45 minus what? L0 is equals to 60, right? 60, we are cross multiplying. 60 open bracket 36 minus L0. So 45 times 40 that will give us 1800 minus 40 L naught is equals to 2160. Yeah, 60 times 36 equals 2160 minus 60 L naught. So from there we collect line times, then we are good to go. So let's bring the L naught, let's bring it to this side, which is our left hand side. Let's bring it here. So that's minus 40 L naught plus 60 L naught is equals to 2160 minus 1800. So here we have 20 L naught, that is minus 40 plus 60 is plus 20, that's 20 L naught is equals to 2160 minus 1800, that will give us what? 360. So divide both sides by 20. So L naught is equals to what? 18 centimeter. Remember your the unit of your length is in centimeter, so this is what? 18 centimeter. That is the original length. Are you getting there? Before forces, are you getting now? Load is applied to the what? To the elastic material. So this is the what? Original length. The original length is what? 18 centimeter. Question 14. The temperature gradient across a copper rod of thickness 0.02 meter maintained at two temperature junction of 20 degrees Celsius and 80 degrees Celsius respectively is A. 2000 Kelvin per meter, 3000 Kelvin per meter for option B. Then C, we have 5000 Kelvin per meter, and this is what? D, 8000 Kelvin per meter. This is not kilometer here, this is Kelvin per meter. Now from here, you know what to do, you know the formula. So sometimes when it comes to JAMB, if you look at your options, there's a way from your options you get the formula to use. Just look at the SI unit. SI unit helps mostly. I get it now. It helps most of the time when it comes to physics. Just look at your SI unit. You are seeing Kelvin here. Yeah? This is Kelvin per meter. So from there, you know, okay, what am I to? That means temperature over what? Meter, right? That's distance or whatever you are over length. So from here now, our temperature gradient is change in temperature over thickness. Change in temperature over what? Thickness. That is for temperature gradient. Now to get this, temperature gradient is equals to, what's the change in temperature? It was 80. You say 80. That is the final. You can see, now if you can decide to convert what's it called, this degree Celsius, you can decide to convert it to Kelvin. If you want to convert it to Kelvin and you convert it to 20 degrees Celsius to Kelvin, by the time you subtract, it is the same thing when you what? Just leave it that way. That means if you don't convert. Now if you want to convert this now to Kelvin, 80 degrees Celsius to Kelvin, that's 273 plus 80, that will give us 353. So let's use 353 here. 353 Kelvin minus, okay, what do you have? 20 plus 273. That's, we are converted to Kelvin now. So it gives us what? 293 Kelvin divided by, what's the thickness? It's 0.02. So the temperature gradient is 353 minus 293. It's still going to give us 80 minus 20. By the time we subtract 80 from 20 from 80, it's still give us 60. So we do the same thing here, it's still give you what? 60. So 60 over what? 0.02. So now the temperature gradient is what? 60 divided by what? 0.02, and that will give you what? 3000 watts Kelvin per meter. So this is how to solve for what? Temperature gradients. And I told you SI units are important. Just look at the SI unit of your what? Of your answers. Even from there, you know what to do. If you are the type that are good with your fundamental and derived quantities. So if you're able to get your SI units, okay, they use this over this. Maybe it was kilogram meter per second square. You know, okay, this is talking about kilogram multiplied by what? Distance, mass multiplied by what's it called? Distance, then divided by what's it called? Time. So from there you are good to go. Question 15. A plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60%. The force parallel to the plane required to push a load 120 Newton uniform up the plane is A. 20 Newton, B. 30 Newton, C. 100 Newton, D. 160 Newton. So let's solve this together. You know, this is an inclined plane. An inclined plane, to get our, what's it called, efficiency. Efficiency when it comes to inclined plane is a mechanical advantage over velocity ratio times 100%. If you want to get our mechanical advantage, it is load over effort, right? Load over effort. And our velocity ratio is 1 over sine theta. If you want to get our velocity ratio. So let's put the values of our parameters there. So a plane inclined at an angle of 30 degrees. So definitely angle is what? 30. So to get the velocity ratio, it gives us what? 1 over sine 30, which is what? 1 over 0.5, which is what? 2. That is velocity ratio. Now I want to get the mechanical advantage. From here now, from questions, we have efficiency. Efficiency was given to be what? 60%. Now we have our velocity ratio. Now we can get our mechanical advantage. If you want to get mechanical advantage from this now, efficiency times, if you look at this, you have a mechanical advantage here, and 100% is 1. So mechanical advantage is equals to what? Efficiency times velocity ratio. Efficiency times velocity ratio give what? Mechanical advantage. So mechanical advantage is equals to what? Efficiency times velocity ratio. So mechanical advantage is equals to, what's our efficiency? 60%, which is 60 over 100, times 2. So that's 0.6 times 2. So mechanical advantage for this question is what? 1.2. It has no unit. Mechanical advantage has no units. Now we've gotten the mechanical advantage, but we can get how are we going to get the effort? That's what we asked for. That is the first parallel to the plane required to push a load. I get it now. You want to carry something, you want to push something, effort is required. So yeah, it is effort. So mechanical advantage is equals to what? Load over effort, right? So how we get effort? Effort is equals to load over mechanical advantage. So effort is equals to, what's our load? Load is what? 120 Newton. So 120 divided by mechanical advantage is what? 1.2. So 120 divided by 1.2 give us what? Effort to be what? 100 Newton. So the correct option here is what? 100 Newton. So that's option C. So it's actually very, very simple. When it comes to your pulley system, you know it is the number of what? Number of pulley. When it comes to inclined plane, if you want to get your velocity ratio, you know it's what? 1 over sine theta. So you have to know the basic thing. So inclined plane, 1 over sine theta for the what? For the velocity ratio. And we can easily get what? Our mechanical advantage. Mechanical advantage is equals to what? Efficiency times velocity ratio. Efficiency is what? 60%. Multiplied by 2 will give us what? 0.6 times 2. That's what? 1.2. That is the mechanical advantage. Then from mechanical advantage is equals to load over effort. Then you make effort the subject of formula. Then effort is equals to load over mechanical advantage. The load is what? 120, and mechanical advantage is what? 1.2. So 120 divided by 1.2 give us what? 100. Question 16. A heater marked 50 watts will evaporate 0.005 kilogram of boiling water in 50 seconds. The specific latent heat of vaporization of water in joule per kilogram is A, 5.0 times 10 raised to power 2, B, 5.0 times 10 raised to power 5, C, 5.0 times 10 raised to power minus 1, D, 5.0 times 10 raised to power 6. So if you come across a question like this in JAMB, it's actually under it. You get me now? It's under it. So if you want to solve a question like this is under what's it called? Specific latent heat of vaporization. This is the formula. Q is equals to LL. Now this L here, it is the latent heat of vaporization. This Q here is the quantity of heat required for vaporization, because we are talking about vaporization in this question. So let's bring out our parameters. We have P to be 50 watts. We have N to be what? 0.005 kilogram. And we have our T to be what? 50 seconds. So we have P, power, time, and mass. Now we don't have quantity. Then how do you get quantity? Remember the formula: quantity of heat is equals to what? Power multiplied by time. Power multiplied by time gives us what? Quantity of heat. So by the time we multiply this, we get our what? Quantity of heat required for what? Vaporization. So power is what? 50 and our time also is what, 50. So quantity of heat required for vaporization is 2500 joules. So now you can make what L the subject of formula, that is you want to get what specific latent heat of vaporization. So LV is equals to what, quantity of heat required for vaporization over mass. Then latent heat of vaporization is equals to quantity of heat required for vaporization, which is 2500. How do you get 2500? Quantity of heat is equals to what, power times time. So 2500 divided by the mass, and the mass is what, 0.005 kilogram. So yeah, by the time you divide, it gives us what, 5.0 times 10 raised to power 5 joule per kilogram. So the basic formula you need to remember, or the key formulas you need to remember when it comes to heat are Q is equals to MC change in theta. That is, your Q, which is the quantity of heat, is equals to mass times specific heat capacity. C is specific heat capacity. I said Q is equals to MC change in theta. Now your Q is the quantity of heat, M is mass, C is what, specific heat capacity. Specific heat capacity, and your theta is what, change in temperature. And you also need to remember Q is equals to ml. Trust me, all these formulas will save you big time. It's going to save you. And you also have your power. You get me now? Your electric, when you be comparing what's it called, household materials. I get it now. You have your power. Your power is equals to I square R. Your power is equals to V square over R. So in some cases, you might not be given the power directly. You might not be given the power directly. So is that they give you what, current and resistance, or voltage and resistance. So either of that, use it to solve your power. Definitely you'll have your time there. From there you can get your quantity of it. Then you are good to go. Question 16. The phenomenon whereby the water droplets in the atmosphere combine with dust particles in the air to reduce visibility. These are the key terms. Reduce visibility. A, fog. B, air. C, mist. D, cloud. Now the correct answer here is mist. Why is it mist? Mist is when dust particles, I get me now, when dust particles, I get me now, accumulate, I get me now, with the water droplets from the atmosphere and blocks vision. People are unable to see. I get me now. Those are what we call what, mist. Why this fog you are seeing here? Fog is an extreme condition of mist. In this case, you won't be able to see at all. You won't be able to see. Fog everywhere will be what? Will be white. Are you getting me now? Everywhere will be white. And when this comes to A is just a droplet of ice from the atmosphere. It happens in foreign countries. So you see that mostly where the weather condition is very okay. Very okay here. We will spoil our atmosphere. So we won't be able to experience things like that. So the correct answer here is mist. Mist is a phenomenon whereby the water droplets in the atmosphere combine with the dust particles in the air to reduce visibility. And cloud, that's precipitation of what's it called, water molecules. I get it now. Precipitation of water molecules. That's what we call what, cloud. So the correct answer here is mist. Question 17. If the wavelength of a wave traveling with a velocity of 360 meter per second is 60 meter, the period of the wave is A, 0.17 seconds, B, 1.2 seconds, C, 1.8 seconds, D, 1 second. Now wavelength, the relationship between wavelength and velocity and period, you have to write that out, which is V is equals to lambda over period. I know most of you are very familiar with V is equals to lambda multiplied by frequency. That is wavelength multiplied by frequency. That is your velocity. But you know, velocity, the period and lambda, you can relate them as what V is equals to lambda over what, period, because your period is equals to what, 1 over frequency, and your frequency is equals to what, 1 over period. So that's why you use what, 1 over period here. That is lambda times 1 will give you lambda, and then we have your period here. So this is the formula for this. So velocity is equals to what, wavelength divided by what, period. So if you want to get your period from here, it will give us a T is equals to what, lambda divided by velocity. So T is equals to, what's our lambda here? Our lambda is what, 60. That's 60 meters. that is wavelength, and you know what wavelength is: distance between two successive crests or two successive stuff. So it's in meters, mostly distance. When you see distance in wavelength, it's talking about what? Wavelength, denoted by what? Lambda. So the velocity is what? What's the velocity? 360 meter per second. So this is 360 meter per second. You can't, let's leave this for now. Let's remove the meter per second. So 0 cancel 0. We have 6 divided by 36. That's 1/6. That will give us 0.17 seconds. So the period is what? Is 0.17 seconds. So if you have to get the frequency from here, what will you do? 1 over period, that is 1 over 0.17. Then you write your what? Your frequency. So just know the relationship. T. What is period? Period is what? T over n. That is time taken to complete what? One oscillation. Are you getting me now? One time taken to complete what? One revolution. And then when it comes to what's it called? Frequency, that's number of oscillation with time, or number of evolution with time when it comes to wave. Number of evolution with time. Are you getting me now? So this is what frequency is equals to what? N over t, and t is equals to what? T over n. So you have to know all those basic formulas when it comes to what? Wavelengths. You have to know them. These are life savers. So that is the correct answer to the 0.17 seconds. So in this case, it is option A. Question 18. A guitar string is 75 centimeters long. The wavelength of the fundamental note is. Now, this question is very, very simple, but you'll find it difficult if you don't know the basics. Are you getting me now? The basics, like when it comes to strings, are you getting now? Vibrating strings, what are the fundamental notes? When it comes to vibrating strings, what are the fundamental notes? When it comes to air column, when it comes to open pipe, when it comes to closed pipe, under wavelength. Are you getting now? What are the fundamental notes? If you don't know them, this question, it is very, very simple, but if you don't know them, it is actually, you will actually what? Fail the question. Now look at this. A guitar string is 75 centimeters long. The wavelength of the fundamental note is. Now look at this. For fundamental notes under vibrating strings, it is L is equals to lambda, that is wavelength divided by 2. Under strings, it is what? Lambda divided by 2. Under what? Strings. But when it comes to air column, it is lambda divided by 4. That is the fundamental note. Lambda divided by 4 when it comes to what? Air column. When it comes to open pipe, it is what? Lambda divided by 2. But when it comes to what's it called? Closed pipe, it is what? Lambda divided by 4. So you have to know all those principles, all those basic principles under what? Wavelengths. You have to be familiar with them. Now, in this case, lambda is equals to what? 2L. That means lambda is equals to what? 2 times our length. So what's the length here? 75 centimeters. So lambda is equals to what? 150 centimeters. That is the wavelength. I get him now, the fundamental note. So the correct option here is option D. Question 19. Now the equation of wave is y is equals to 0.005 sine open bracket pi open bracket 0.5x minus 200t close brackets, and you have your giant bracket. Now where x and y are in meters and t is in seconds, what is the velocity of the wave? Now A, we have 100 meters per second, B, we have 150 meters per second, C, we have 300 meters per second, and D, we have 400 meters per second. Now in this case, all you just have to do is, if you can actually remember your standard wave equation. You know our standard wave equation, we have, for standard wave equation, we have y is equals to a sine 2 pi x over lambda minus what? 2 pi ft. Now this is our standard wave equation, a sine 2 pi x over lambda minus 2 pi ft. Now we are asking for the velocity. All you just have to do now is just compare. You compare the equation we're given in the question is y is equals to 0.005 sine open bracket okay, let's turn this into a single equation, right? You know we have pi here. Let's use pi to multiply the bracket, so it gives us 0.5 pi x minus 200 pi t. So this is the equation we're given in what? In the question. So what we just have to do now is what? Compare. Now look at this. A sine, that means our A is what? Our amplitude is what? 0.005 here. Amplitude, that's maximum displacement. So we have 2 pi x over lambda. That here we now have what? 0.5 pi x. That means we have to equate them. That is 2 pi x over lambda is equal to what? 0.5 pi x. Now from here we want to arrive at something. We want to get something here, which is lambda. Are you getting me now? I'll tell you why we want to get lambda later. Now look at this. We have pi, we cancel pi, right? Pi, we cancel pi. X, we cancel x. All we now have left is what? 2 over lambda is equal to what? 0.5. Definitely lambda is equal to what? 2 divided by what? 0.5. You get me now? That means our lambda is equal to 2 divided by 0.5, and 2 divided by 0.5 will be also 4. That is 4 meters. We have lambda to be what? 4 meters. Now let's look at this. If you look at this second part, we have minus 2 pi ft. Here we have minus 200 pi t. Now look at this point. I'll use this point. Now look at this. You just have to equate it also. 2 pi ft is equal to what? 200 pi t. 2 pi ft is equal to what? 200 pi t. Now here you can say pi will cancel pi, t will cancel t. We now have 2f. 2f is equal to what? 200. Definitely we divide both sides by what? 2. Then f equals to what? 100 hertz. F is equals to what? 100 hertz. Now look at it. We arrived at, we got our what? Lambda here, and we got our what? F here. And if you can remember, velocity is equals to what? Lambda times frequency. That is why I solve for lambda here and I solve for what? Frequency here. All you just have to do is what? Equate what you have in your normal or your standard wave equation, equate it to what you're given. Are you getting now? This side now you have 2 pi x over lambda, equate it to what you have 0.5 pi x. Then from there you're able to get your what? Lambda. Are you getting now? Because others will cancel other, pi will cancel pi, x will cancel x. All you have left is also your lambda. You'll be able to get your lambda. The second part also, 2 pi ft is equal to 200 pi t. So equate it also. So 2 pi ft is equal to 200 pi t. Pi will cancel pi, t will cancel pi t. So we now have what? 2f equals to what? 200. Then from there you divide both sides by 2. Then f equals to what? 100 hertz. Don't forget the SI unit of frequency is what? Hertz. H-E-R-T-Z. That is hertz. And your lambda is what? 4 meters. So and v is equals to what? Lambda times frequency. So v is equals to what? 4 times 100. So velocity is equals to what? 400 meter per second. So the velocity here is what? 400 meter per second. So the correct option here is D. So don't be afraid of wave equation questions. All you just have to do is what? Bring your all of them in the brackets, compare. I get in and compare and contrast. Okay, this one is equal to this. If I'm able to cancel out this, I will get this. If I'm able to cancel out this, I'll be able to get this. So just remember your standard wave equation. It is very, very simple. By the time you get yourself familiar with a lot of questions under wave equations, you won't have to calm the formula again. Y is equals to a sine open bracket 2 pi x over lambda minus 2 pi ft. You get me now? It is very, very simple. And your 2 pi f is same thing as what? Your angular velocity. If you can remember, 2 pi f is equals to what? Angular velocity. So you can actually see them putting what? Calculate the angular velocity. All you just have to do is what? 2 pi f is equals to what? Angular velocity. What is your pi? 3.142. What is your frequency here? It is what? Frequency is what? 100. So you are good to go. So if you see questions like this, don't be afraid. All you just have to do is what? You have to know your standard wave equation. It is very, very important. I get you now, even just for that day. Even just for a day. Just know it. Then from there you'll be able to what? Compare and contrast with whatever you are given. Whatever equation you are given, you're able to what? Compare. So that is all. Question 20. Now look at this. The velocity of a sound wave at 27 degrees Celsius is 360 meters per second. Its velocity at 127 degrees is A, 240 meters per second, B, 180 root 3 meter per second, C 140 meter per second, D 240 root 3 meter per second. The answer is, you have some options there in sword, so you know you have to solve using what sword also here. So now solution, look at this. The first thing is to look for the relationship between velocity and temperature. And the relationship between velocity and temperature, velocity is directly proportional to what? Square root of temperature. Velocity is directly proportional to square root of temperature. And whenever you see directly proportional, that means increase in one will lead to increase in the other. In this case now we are talking about velocity and temperature. That means increase in velocity will also have what? Increase in temperature. If your temperature or your velocity was actually maybe 360, then you increase it to like 420, definitely the value of your temperature will also what? Increase. So that is the meaning of directly proportional. But if you see inversely proportional, inversely proportional, increase in one will lead to a decrease in one. Decrease in one will lead to what? Increase of the other. So if we have just like this your what's it called? Your boys that said pressure is inversely proportional to volume. When it comes to both, that means pressure, and increase in pressure will lead to a decrease in volume, or increase in volume will lead to a decrease in pressure. That is it. So in this case now, what I just want you guys to know is how you will be able to like what's it called? Cancel some options. How you will be able to cancel some options in exam. Now in this case now, look at this. The temperature was 27 degrees Celsius. Then the velocity was 360 meter per second. The velocity increased, right? 127. Now what will happen to the velocity too? The velocity also will what? Increase. The velocity also will what? Will increase. Definitely. Look at this. Even from here, you should be able to know the answer from the options. That is 240. That means it's less than 360. It can never be 240. 180 was 3. Maybe if you multiply 180 with 3, if you get anything below 360, you know it is not this. 140 can never be 140. So here we just have B and D now. So let's solve using what? The relationship V is directly proportional to a square root of what? T1. So we have V1 over square root of T1 is equals to V2 over square root of what? T2. Then from here, we are going to what? Cross multiply, because you want to get what? V2, right? That's what we're asking for, velocity. So if you want to get V2 now, it will give us V2 is equals to V1 T2 over T1. By the time you collect like terms, I get it now. If you don't want to put it this way, you can definitely put it this way. V1 square root of T2 over what? Square root of what? T1. Any way you want to put it, still the same thing. So now let's continue. We now have V2 is equals to what's our V1, which is velocity in this case. Velocity is what? 360 times root. What's our T2? 127. So sorry, in this case you convert it to what? Kelvin. So 127 plus 273 to give us what? 400. So in this case you use what? 400. Now let's go to the other one. We have what? 27 here. 27 plus 273 to give us what? 300. So we have square root of what? 300. Here now we are good to go. If you are good with sword, you are good to go from here. So velocity, that is the second velocity, V2 is equals to 360 times 20 over, now what is 300? That's, you have to look for one to be a perfect square and the other is not a perfect square. That is 100 times what? 3. Then 100, you can say 100 times 3. I'm teaching you guys all here. So V2 is equals to what? 360 times 20 over with 100 times root 3. That's root 100 is what? 10 root 3. So from here you are good to go. You can say 10 year 1, 10 year 2. So we now have 360 times 2, which is 720. 720 divided by root 3. So from here, rationalization, you can say divide both sides by root 3 divided by root 3. So what will happen? Root 3 times root 3 will give us root 3. So we have 720 root 3 over 3. So 3 year 1, 3 year 240. So the correct answer is 240 root 3. That is option D. So in some cases, if you don't have time, you can do minimum, and my one advice is to do that, just solve, be time conscious, and you know what you are doing. So I just taught you guys how to what? Minimize the options. From before I started the question, I reduced my options to what? Just 2. I removed A and C. I told you guys the answer will surely be what, B or D. Why? It's not because they are in soft form. It's because our A and C are less than 360, and from the relationship we said what V is directly proportional to T. That means increase in temperature will lead to what? Increase in velocity. So it was 27 here and it increases to 127. So definitely our temperature will be what? More than 3. Our velocity, sorry, will be more than what? 360 meter per second. So that is all. Question 21. Which of the following is not a characteristic of longitudinal wave? Now, if you want to answer questions like this, you have to know what longitudinal waves are, and you have to know the types of waves you have. You know, we have longitudinal wave, we have transverse wave. I get it now. And you know what is longitudinal wave, what is transverse wave. Longitudinal wave, you know, what's it called? Wave direction is perpendicular to the what? To the vibration. Wave direction is perpendicular to what? To the vibration when it comes to the directional wave. But when it comes to transverse wave, it is parallel. I get it now. Wave what's it called? Wave direction is parallel to the vibration. I get it now. To the direction of the vibration. Wave direction is what? Parallel to the direction of the vibration when it comes to what? Transverse wave. But when it comes to longitudinal wave, what do we have there? We have what? It is perpendicular. That means for what's it called? For transverse wave, the direction of what's it called? The direction of wave and vibration. I get it. They having what? The same direction. Direction of wave and direction of vibration are the same. They are moving in same direction. But when it comes to longitudinal, it is perpendicular. I get it now. It is perpendicular. It's not moving in the same direction. Let me put it that way. Not moving in the same direction. That means your wave direction is not the same. It's like wave direction is not the same with what vibration. I get it now with the direction of vibration when it comes to longitudinal wave. Now we have to start with all these terms, which are the what properties of wave. We have polarization, diffraction, reflection, and refraction here. Now these are the properties. One here is not a property of polarization or of longitudinal wave. And now the first one we have polarization. What is polarization? From polarization, when rays of light, I get it now, are moving in the direction of the what? Of the vibration. When the wave particles are moving in the direction of the vibration, that is polarization. So definitely, you know our answer now. Diffraction. What is diffraction? When wave comes with when they what's it called? When they meet an obstacle in their line of propagation. I get him now, and they are able to bend around that obstacle. I get him now, and continue their propagation. So that is what diffraction is all about. Well, when it's a wave bends around its obstacles and continues is what it's propagation. Reflection. What is reflection? Reflection is change in speed. Reflection is change in speed. I get it now. And mostly, what reflection entails? What causes reflection? Now look at it. There are some things we call reflected rays. Now reflected rays. Now let me talk about this. When lights, I get it now. Rays of light are being are propagated. Now it comes or it meets a plane barrier. That plane barrier will cause an obstruction. That obstruction will now lead to what? The bouncing back of rays. That rays are what we call reflected rays. The rays that bounces back after hitting a plane barrier. I get him now. So you can see that's what the reflected rays. So that process is what we call reflection. When the reflected rays or when rays are shined on what or are propagated on the surface, and what will happen? The rays bounces back. You can see those are what that process is what we call reflection. But the incident rays are those ones that hit that surface. I get him now. I said the reflected rays are those ones that are shined, that bounces back. I get him now. Reflection that bounces back. Those are the reflected rays. But those ones that hit the surface are what called the incident ray. And in between your incident rays and your reflected rays, you have what is called your normal, or in between your normal, in between your reflected angle and your incident angle, you have what is called your normal angle. So in this case, it is polarization because it is an attribute of longitudinal wave. We said they are they move perpendicular. Are you getting now? They move perpendicular. That is, wave particles move perpendicular to the direction of the vibration. So in this case, polarization now is not an attribute of longitudinal wave, because polarization deals with when wave particles are moving to the direction of the what of the vibration. I get it now. So you say the correct answer here is polarization. Polarization is not an attribute of what? Longitudinal wave. And examples of longitudinal wave, you have what? Your sound wave. Transverse wave, you have also what we call your water wave and the electromagnetic wave in form of radio and light. Those are electromagnetic waves. So those are transverse wave. And longitudinal wave, you have what? Your sound wave. So you have to know that polarization is not an attribute of what? Longitudinal wave. And I explain longitudinal wave to you guys. So that is all. Question 22. An object 15 centimeter high is 30 centimeter from a pinhole camera. If the height of the image formed at the back of the camera is 10 centimeter, the image distance is A 10 centimeter, B 15 centimeter, C 25 centimeter, D 20 centimeter. Now this is a question. This question is actually related to what? Mirrors. Are you getting me now? Under what is called refraction of light. So now look at this, and the mirror formula, if you can remember, is ID over OD is equals to what? IH over OH. Now you have to identify all these things from your question. Now look at this, let's read it together. An object 15 centimeter high, that means object's height is 15 centimeter. Is 30 centimeter from a pinhole camera, that means object distance 30 centimeter. If the height of the image formed height of the image, that is image height. Are you getting me now? Image height at the back of the camera. So at the back of this camera, you know it is a virtual image. Now is 10 centimeter, 10 centimeter, 10 centimeter at what? At the back. So the image height is 10 centimeter, the object height is what? 15 centimeter, and the object distance is what? 30 centimeter. From here, you are just left with your ID, which is what? Image distance. So if you want to calculate, use this formula. ID, we're not given, so ID over OD, which is 30, is equals to what? IH, what is our IH? 10, and OH is what? 15. Right? OH is what? 15. So from here, we are good to go. So from here, you can cross multiply. By the time you cross multiply, then so let's cross multiply. We have 330 times 10 is equals to 15 times ID. So from here, this will give us 300 is equals to 15 ID. Then 15 here, 15 in 300 is what? 20. So our image distance is equals to 20 centimeter. So that is on the mirror. Question 23. An object is placed 10 centimeter in front of a concave mirror of focal length 15 centimeter. What is the position and nature of the image formed? A 30 centimeter and real, B 30 centimeter and virtual, C 50 centimeter and real, D 50 centimeter and virtual. Now if you see something like this in JAMB, this is how you tackle it. Now look at this. An object is placed 10 centimeter in front of a concave mirror. Now let's write our mirror formula, those that remember. Now look at this, this 1 over V plus 1 over U, or you say, let's go like this, 1 over U plus 1 over V is equals to 1 over F. 1 over U plus 1 over V is equals to what? 1 over F. Now, and if you look at this, I told you anything related to U, is trying to tell us that that's what? Object distance. That is U. U is object distance. U is equals to what? Object distance. While V is equals to what? Image distance. Now let me add this to this. Magnification. Now if you ask me for magnification, it's the ratio of what? Image distance over what? Object distance. Magnification, you might ask, what's the magnification of the what? Of the image? I get me now. So you might, okay, that's what? V over U. Magnification is equal to what? V over U. That is image distance over what? Object distance. Now in this case, object distance is what? U, and image distance is what? V. So, and we have our F to be our what? Focal length. Focal length. That is our F. F is what? Focal length. Now from here, an object is placed 10 centimeter in front of the concave. That's what? Object distance. And object distance is what? U. That means U is equals to what? 10 centimeter here. Of the concave mirror, our focal length 15 centimeter. That means our focal length here is what? 15 centimeter. Do you get me now? And let me add to this. Look at this concave mirror. Concave mirror are what? Converging mirror, and your convex mirror are what? Diverging mirror. The reverse is a lens. So I said concave mirror is what? A converging mirror, and your convex is what? A diverging mirror. Now let's continue. We have 1 over, what's our U? Our U is 10 plus 1 over V is equals to 1 over 15. Then from here we can solve. We can say 1 over V is equals to what? 1 over, make collect like times 1 over 15 minus 1 over 10. So 1 over V is equals to what? Square, what's the LCM of 15 and 10? It is 30. So from here, 30 divided by 15 gives us 2. 2 times 1, 2. So minus 30 divided by 10 is give us what? 3. 3 times 1 give us what? 3. So we are good to go. We have 1 over V is equals to what? 2 minus 3. What is 2 minus 3? It is minus 1. 2 minus 3 is what? Minus 1 over 30. Then you what? You cross multiply. We now have minus V is equals to what? 30. Then from here, divide both side by minus 1. Then we have V is equals to what? Minus 30. Now look at this. Our V is having, which is the image distance, is having what? Negative sign, right? V is having what? Negative. So in this case, it is a virtual image. I get it now. It is a virtual image. If you are seeing a negative distance in front of a negative sign, I get me, in front of your V, which is your what? Image distance. It's trying to tell you that it is what? A virtual image. So yeah, it is 30 centimeter and the image is what? Virtual. So that is option B. Question 24. A beam of light is incident from air to water at an angle 30 degrees. That's the angle of incidence from here. Find the angle of refraction if the refractive index of water is 4/3. Now in this case now, if you can remember, how do you get refractive index? You can remember from Snell's law, that is refractive index is equals to sine I over what? Sine R. Right? That is Snell's law. That is sine of the angle of incidence over sine of the angle of what? Refraction. So you have this sign you are seeing here. It is for refractive index. Then what is our refractive index from the question? It's 4/3. What is angle of incidence? It is 30. So we have 4/3 is equals to sine 30 over sine R. So we now have to cross multiply, right? Then we can say sine 4 sine R is equals to what? 3 sine 30 degrees. Then divide both side by 4 first, right? So this will give us 4 will cancel 4. We now have sine R is equals to what? 3 sine 30. That's 3 times 0.5 over 4. Then sine R is equals to what? 1.5 over 4. And the 1.5 is the same thing as 3/2. So we can say 3/2 sine R is equals to 3/2. 1.5 is the same thing as 3/4. The same thing as 3/2. Then we can say 3/2 divided by 4. Then we can say 3/2 times 1/4. That is 3/8. Sine R is equals to what? 3/8. We asked you for the what? Angle of refraction. So in this case, it will be R. R is equals to sine inverse of 3/8. And what is sine inverse of 3/8? Use your calculator to give you what? Approximately 22 degrees. So that is the angle of what? Refraction. And if they ask you what is Snell's law, that is the sine of the angle of what? Refraction over sine of the angle of what? Sine of the angle of incident over sine of the angle of what? Refraction. Will give you what? Refractive index. So that is all on all. question 24. Question 25. When white light is dispersed by a spectrometer, the component having the shortest wavelength is A. Red, B. Orange, C. Indigo, D. Violet. Now look at this question. What are the components of your white light? You have your Roygbiv. Roygbiv. R for red, orange, yellow, green, blue, indigo, and violet. Now they are arranged in order of decreasing wavelengths. They are arranged in order of decreasing wavelengths. This order, don't mix it. They gave it Roygbiv. Roygbiv. That is R for red, O for orange, Y for yellow, G for what? Green, B for blue, I for indigo, and G for violet. I said they are arranged in order of what? Decreasing wavelength. So now that means the one with the highest wavelength here is what? Red. I get it. So I said decreasing wavelength. So it's decreasing all the way to what? V. That means the one with the shortest wavelength here will be what? V, which is the violet. I get me now? Will be the what? Violet. So the components, the 7 components of your white color, know them. That is red, orange, yellow, green, blue, indigo, and violet. Then you know that what they are arranged in order of what? Decreasing wavelength. I get me now? They are arranged in order of what? Decreasing wavelength. So in this case, the one with the shortest wavelength here is what? Violet, and the one with the highest wavelength is red. So in this case, we are asked for what? The one with the shortest wavelength, which is what? Violet in this case. So the correct option is D. Question 26. Which of the following electromagnetic waves has the highest frequency? A. Infrared, B. X-rays, C. UV rays, D. Radio wave. Now I'm going to give you what we call the electromagnetic spectrum, the way they are arranged. Now these arrangements, it has to do with decrease in the wavelength and increase in frequency. Now look at this. We have R, M, I, V, U, X, G. Now these are all electromagnetic waves. Now but the way they are arranged here, they are in order of decreasing wavelength and increasing frequency. Decreasing wavelength, that is all the way from radio wave to gamma wave, we have a decreasing what? Wavelength, and all the way from what? Radio wave to gamma, we also have what? Increasing frequency. Now here, this is radio wave, these are electromagnetic wave, and you must know they have the same speed as visible light. I get it now, which is 3.0 times 10 raised to power 8 meters per second. That is for velocity of light. I get it now. So they have the same speed. So your radio wave, microwave, what's it called? Infrared, visible, UV ray, X-ray, and gamma rays all have the same what? Speed with what? Visible light. You need to know that. This is microwave. We have infrared. You also have visible light. You also have UV rays. These are all, they are what? Electromagnetic wave. You have X-rays and gamma rays. Now look at this. I said they are order of what? Decreasing wavelengths. You have to know this. Decreasing wavelengths. Write it somewhere, please. Decreasing wavelengths. This is decreasing wavelengths. That is, the wavelength is what? Is decreasing. I get him now. Maybe it was 5 here. That means anything from year to year. I get him now. It's kept on what? Decreasing. I get him now. Then the frequency what? Increases. So the frequency what? Increase. That means increase in frequency. Over here, you have increase in frequency. All the way from radio wave to what? Gamma wave. You have what? Increasing frequency and decreasing wavelength. So definitely the one with highest wavelength here will be what? Radio wave. So the one with the lowest wavelength will be what? Gamma rays. The one with the highest wavelength is what? Radio wave, and the one with the what? Lowest, what's it called? Wavelength will be what? Gamma rays. Then the one with the lowest frequency will be what? Radio wave. While the one with the what? Highest frequency will be what? Gamma rays. So I told you guys what? Downward, I get you now. There's increase in frequency, and downward there's what? Decrease in wavelength. So let's go back to our question. Which of the following electromagnetic wave has the highest frequency? And I said there's increase in frequency in what? In the downward thread. I get the downward thread, there's what? Increase in what? Frequency. So the one with the highest frequency will be the one last year. That's the gamma rays. Do you have it here? The gamma rays. We don't have gamma rays. Okay, let's look at what we have. Do we have X-rays? Okay, we have X-rays. So X-rays is one closer towards gamma. So we have X-rays. The answer is what? X-rays. That's one what? Highest frequency in this case. Question 27. This is a capacitor. I get it now. Now look at this. Calculate the total capacitance. A, we have 2 number 10/13 microfarad. B, 2 number 1/3 microfarad. C, 4 microfarad. D, 3 microfarad. Whenever I see micro, you know it's times 10 to the power minus 6. So you can do your maths there. Micro is what? Times 10 to the power minus 6. Now in this case, now just have to study the arrangement. Are you getting now? This is parallel arrangements. Are you getting now? These are parallel arrangements. This is what? Series. Are you getting now? This is series and this is parallel. Now under capacitance, for capacitance, now for parallel arrangements, total capacitance, are you getting now? For parallel is what? You add capacitance 1 plus 2 plus 3. The first capacitor with the second capacitor and the third capacitor, just add them together. That's for parallel arrangement. So in this case, 4 plus 3 plus 2. 4 plus 3 plus 2. That's, let's just say 4 microfarad plus 3 microfarad plus 2 microfarad. So what will be our total capacitance for our parallel arrangement? It will be what? 9 microfarad. That is for the parallel. Why for we only have one? I get it now. We only have one series. I get it now. One series, which is the 4 microfarad. So in this case, to get the total capacitance of the capacitor, you have to use this. Now total capacitance will now be, you know, this is in parallel. So this is 1/4 microfarad, or you can just, for this, let's just remove the microfarad for now, plus 1/9 microfarad. Now this is also in series. Also now this is in series. I get it now. You're getting the total capacitance of the parallel. So it's now in series. So you have to what? Use this formula: 1/CT plus 1/C1 plus 1/C2. That is the capacitance, first capacitance and second capacitance. Or you make use of R times, C1 times C2 over C1 plus C2. Alright, either of the formula, but let's stick to this. We have 1/CT is equals to, what is the LCM of 4 and 9 is 36. So LCM of 4 and 9 is 36. 36 divided by 4 will give you 9, plus 36 divided by 9 will give us 4. That is 9 plus 4 to give us what? 13. So we now have 1/CT. That is, CT here is what? Total capacitance. So 13/36. 13/36 in this case. Now 13/36. So we cross multiply. We now have 13 CT is equal to what? 1 times 36. So 13 CT is equal to what? 36. So divide both side by what? 3. By 13, sorry. Divide both side by 13. So we now have CT, which is the total capacitance of this capacitor. But that will be 36/13. That is 2 number 10/13 microfarad. That is the total capacitance. If you see questions like this, all you just have to do is solve for the parallel first. I get me now. Solve for the parallel arrangement by adding them individually, add them together. So your total capacitance for your parallel arrangements, combine it in series. to your what, to the series, the capacitance or the capacitor. I get it now, that arranged in series. So that is how you solve questions like this. So here we have 4 microfarad here, so I just have to combine it with the what, my total capacitance for my parallel arrangement. I know resistors and parallel are vice versa. Resistors and their capacitance are vice versa. For resistors, you know, for resistors you have parallel, you have to do 1 over R1 plus 1 over R plus 1 over R2 is equals to 1 over R2. That is the total what's it called, total resistance. But you now have the series arrangement to be R1 plus R2, but in capacitance it is the reverse. So in this case it will be 1 over CT, that is, CT is your what, total capacitance, equals to what, 1 over C1 plus 1 over C24. That means if you have 2 capacitors, I get me now, in this case it will be what, 1 over CT is equals to 1 over C1 plus C2 for what, series arrangement. So know the differences for series resistors in series and capacitors in what, in series. So you just have to know the arrangement. So that will be all. So the right answer here is A, 2 whole number 10 over 13 microfarad. That is the answer. Question 28. Calculate the force acting on an electron of charge 1.6 times 10 raised to power 19 coulomb, placed in an electric field of intensity 10 raised to power 8 volts per meter. This is 10 raised to power 8 volts per meter. Now look at the options. They said A, we have 1.6 times 10 raised to power minus 11 Newton. B, 1.6 times 10 raised to power minus 10 Newton. C, 1.9 times 10 raised to power minus 15 Newton. D, 1.7 times 10 raised to power minus 12 Newton. So in this case, all you have to do now is, now the formula is F is equals to Q, that is here quantity of charge times field intensity. I get it now. Quantity of charge times what, electric field intensity, to get your force in this case. So force is now equals to us quantity of charge we have here. It is 1.6 times 10 raised to power minus 19. So 1.6, so please, 1.6 times 10 raised to power minus 19 times, what do you have here, 10 raised to power 8. (1.6) times 10 raised to power minus 19 times 10 raised to power 8. Now from your indices, you know the logic. This is plus, I get it now. So you add what, the power. So minus 19 plus 8 to give us what, minus 11. So from here you have F is equals to 1.6 times 10 raised to power what, minus 11. How did I get my minus 11? From indices you have 10 raised to power minus 19, 10 raised to power 8. Pick 110. I get it now. So minus 19 plus 8, it gives us what, minus 11. So we have 1.6 times 10 raised to power what, minus 11. That is option A in this case. So that's how to solve what, force when given your field intensity and your quantity of charge. Force is equal to what, the product of what, quantity of charge and electric field intensity. Question 29. The 3 capacitors of capacitance 2 microfarad, 4 microfarad and 8 microfarad are connected in parallel, and the PD of 6 volts is maintained across each capacitor. The total energy is A, 300 joules, B, 252 joules, C, 302 joules, D, 150 joules. Now in this case, you just have to look for what's it called, energy in respect with your what's it called, your capacitance and your voltage or your potential difference there. So now look at this. When it comes to looking for total energy in the capacitor, we have these are the formulas we have. We have total energy, let me use E, 1 over 2 CV square, or you can say let's use Q square over 2C. That is quantity of charge over 2 times capacitance. Then you have average capacitance times what, voltage square. So now in this case, we have E is equals to 1 over 2 times. Now, what's the capacitance here? Now, before that, look at 3 capacitors of capacitance 2, 4, and 8 microfarad are connected in parallel. So, if capacitors are connected in parallel, so what will happen? Just add them when it comes to capacitor. And I told you earlier that when it comes to resistor, you have to use the inverse of C R1 plus R2 1 over R1 plus R2. But when it comes to capacitance, the parallel aspects, just add them. Do you get me now? Add them. So in this case, you just add 2, 4, and 8 microfarads together. You get the total capacitor or the total capacitance. So the total capacitance here is what? 14 microfarad. That is total capacitance is equals to 2 microfarad plus 4 microfarad plus 8 microfarad. So in this case, CT is equals to what? 14 microfarad. When arranged in what? Parallel connection, just add them. If in series, that is when you'll be applying 1 over C1 plus 1 over 2 in capacitors. In capacitors, please know the differences. And now, C, what is the total capacitor? We have 14 times, what is our V? 6, so 6 squared. So we now have E, which is energy, 1 over 2 times, that's 2 year 1, 2 year 7. So we now have 7 times 36, that's 252 joules in this case. So the correct option here is option B, 252 joules. That means E is equals to 252 joules. So in case you are not given V and you are given quantity of charge, you can use E is equals to Q square over 2C. Are you getting me now? Q square over 2C, or you say 1 over 2 CV square. So it depends on the question you are given.
Started now.
Question 30. A cell of EMF 2V, that is 2 volts, and internal resistance 1 ohm supply a current of 0.5 ampere to a resistance whose value is A, 3 ohm, B, 4 ohms, C, 5 ohms, and D, 6 ohms. Now in this case, you just have to remember what's it called, the relationship, the formula that combines your voltage, that combines resistance, and at the same time combines your current. So if you look at what we're given in the question, we have E, which is the EMF, to be 2V, and we have the internal resistance in this case. Internal resistance, that is your small letter R, internal resistance. So it is 1 ohm. Supplies a current of 0.5. That means I, which is the symbol for current, is 0.5 ampere to resistance. Now that's the total resistance, which will be our big R in this case. Now the formula we have to use here is E is equals to I, open bracket, our total resistance plus internal resistance. So we just have to substitute our values into this formula. So we have E is 2, right? 2, which is EMF is 2, and our I is what? 0.5. Our R, big R, we're not given. That's total resistance we actually look for. R plus. Now we now have our what? Internal resistance to be what? 1 ohm. So we have 1 in this case. So you can solve this way. Is either you clear the brackets first, you expand the brackets, or you divide by 0.5. By the time you divide by 0.5, 0.5 will cancel 0.5. So we have 2 divided by 0.5 is equals to R plus 1. 2 divided by 0.5 is equals to R plus 1. Then 2 divided by 0.5, that's 2 divided by half. Will give us what? 4. 2 divided by half will give us 4. Then in this case we have R plus 1. Then if we want to get our total resistance, we give what? R is equals to what? 4 minus 1. So we have our total resistance is what? 3 ohms. So the correct option here is option A. Question 31. A house has 10 40 watts and 500 watt bulbs. how much will it cost the owner of the house to keep them lit for 10 hours if the cost of a unit is 5 naira? That means per unit the cost is what? 5 naira. So let's write out the parameters first. The house has 1040 watts. 1040 watt, that is power. So we have power of a bulb is 40 watts. We now have 1040 watts, right? That will be 10 times 40 in this case. 10 times 40 or 40 times 10, that will give us what? 400 watts for the what? First 10 bulbs. Now, and 500 watt bulbs. So that will be power of the other bulb. Will be 100. That means we have 500 watt bulbs. So 5 times 100. So in this case, it will be what? 500 watts. So now, to get the total power of the bulbs, let's just say power of bulb, the first bulb, yeah, and the power of the second bulb. Let's just add them together. That will be 400 watts plus what? 500 watts. So that will be what? 900 watts. That is the total power consumed by the what? By the bulbs. Now, how much will this cost the owner of the house to keep them lit for 10 hours? Now, electrical energy is equals to power times time. Power multiplied by time. That is electrical energy. So now, electrical energy is equals to, now what's the power? The total power we have here is 900. Now, what's our time? We said 10 hours, right? So, multiply by 10. Now, there's a reason why I'm not converting this to seconds. In this case, when it comes to current electricity, it's always in kilowatt hour. Are you getting now? Electrical energy is always in what? Kilowatt hour. They use the PACN standard. Are you getting now? That's what they use here. And the PACN standard is kilowatt hour. Now, in this case, 900 times 10 give us what? 9,000 kilowatts. Sorry, 9,000 watts hour in this case. First, watts hour. Now, if you want to convert it to kilowatt hour, that means you divide by what? 1,000 kilowatts. Kilo, that's 10 raised to power 3. So you divide by what? 10 raised to power 3, that is 1,000. So in this case, 0 will cancel 0. We have what? 9 kilowatts hour. That is for electrical energy. It's what? 9 kilowatts hour. For the what? For the bulbs, all the bulbs. You know, we have 10 40 watt bulbs and then 5 40 watt bulbs with a total power of 900 watts. So the total energy is what? 9 kilowatt hour. So all this converts to kilowatt hour when it comes to what? Electrical energy. Always convert to kilowatt hour because that's the standard that PACN use. So this is 9 kilowatt hour. Now we now have, if the cost of a unit is 5 naira. Now we now have what? How many units here? We have 9 units here. And they said if the cost of a unit is what? 5 naira. That means per 1 kilowatt hour. I get me now. We have what? 5 units. So in this case now we are now having what? 9 kilowatt hour. So it will be what? Total cost. Let me use this way. Total cost will be equals to what? 9 times 5. And you can tell me what 9 times 5 is. It is 45. So the cost will be in naira. I get me now. So that's 45 naira. That is the cost of operating 10 40 watt bulbs and 500 watt bulbs. So it will be what? 45 naira. Question 32. Look at this. You have calculated the mass of the copper deposited during electrolysis when a current of 4 ampere passes through a copper salt for 2 hours. Now, if you have your electrolysis constant, your Z, I get me now, that's 3.3 in this case. So it varies, depends on the question. So always check your constants when it comes to when you are solving electrolysis. It is not standard. I get it now. Some might use the standard, but when it comes to JAMB also, you see different values. I get it now. So in this question, the use of Z to be equal to 3.3 times 10 raised to the power minus 3 kilojoule per coulomb. Kilojoule per coulomb. That is the SI unit for the constant. Now look at this electrochemical constant. Now look at this. We have the first option to be 90 kilogram, B 95 kilogram, C 80 kilogram, D 60 kilogram. Now let's solve this together. Let's write out our parameters. We have to calculate the mass. That means we have the mass. The mass of copper deposited during electrolysis when the current of, that means I, which is the symbol for current, is 4 ampere. The current is 4 ampere. Passes through a copper source for 2 hours. That is the time. Time is 2 hours. Now convert to seconds. If you want to convert to seconds, that's 2 times 60 times 60. Why am I using times 60 times 60? That is 60 seconds make 1 minute and 60 minutes make 1 hour. So that's why I'm using 60 times 60. That is for 60 seconds for 60 minutes. Then we are now having 2 hours. That will be 2 times 60 times 60. So 2 times 60 is 120, and 120 times 6 will give us 7,200 seconds in this case. So the time is 7,200 seconds in this case. We now have N is equals to ZIT. Now, from our first law of electrolysis, it states that mass is directly proportional to the quantity of charge. So from there, we know quantity of charge Q is equals to what? IT. Q is equals to what? IT. So that's why we are saying this IT here. N equals to what? ZIT. And this Z is our electrochemical constant. Now look at this. M is equals to 3.3 times 10 raised to power minus 3. That is the electrochemical constant Z, times what is our current? It is 4. And what is the time? The time is 7,200. Now if you solve for this, it will give you, multiply everything to give you 95 kilogram. So that is the mass of copper deposited during the electrochemical process. Now look at this. So we have B. That is option B is the right answer to that. So 95 kilogram. That is the mass of copper deposited during electrolysis when the current of 4 ampere passes through a copper source for 2 hours. 95 kilogram. Question 33. A proton moving with a speed of 1.0 times 10 raised to the power 6 meter per second through a magnetic field of 1 Tesla experiences a magnetic force of magnitude is 8.0 times 10 raised to the power minus 14 Newton. The angle between the proton velocity and the field. Now they are trying to tell us that, okay, what's the angle between what? The proton velocity and the field. So in this case now, the formula that is relating proton velocity and field is F is equals to B QV sine theta. Now this is the formula that is having force, field, quantity of charge of proton, velocity, and our angle. So this angle here is this angle between what? The proton velocity and the field. So F, so let's make sine theta the solution of formula. So sine theta is equals to what? F over BQV. In this case, BQV. F equals to what? Sine theta is equals to F over BQV. So sine theta equals to what's our F? That's the force. The force says 8.0 times 10 raised to the power minus 14 Newton. And our B, which is our field, magnetic field, is 1 times. Now, what is our quantity of charge of a proton? I get me now. Quantity of charge. I get him now of proton is constant. Is 1.6 times 10 raised to the power minus 19 coulomb 1.6 times 10 raised to power minus 19 coulomb. So here the quantity of charge of photon, I get me now, is 1.6 times 10 raised to power minus 19 coulomb times the velocity here. And what's the velocity? The velocity is what? 1.0 times 10 raised to power 6 meter per second. So you can divide. If you divide this, sine theta, now you say 8.0 times 10 raised to power minus 14 divided by, let's say, 1.6 times 10 raised to power minus 19 here. By the time you multiply, it will give you 1.6 times 10 raised to power minus 13. So we have 8.0 times 10 raised to power minus 14 over 1.6 times 10 raised to power minus 13. So we have here we have 8.0 times 10 raised to power minus 14, and we have 1.6 times 10 raised to power minus 13. So you can do this. You take the numbers. I get it now. Take the numbers and pick the ones that are having powers separately. So you can say 8.0 divided by 1.6 times 10 raised to power minus 14 minus 13. Minus 13. So that will give us what? Plus 13. So we're having minus 14 plus 13 here. Minus 14 plus 13. So 8.0 over 1.6 times what? 10 raised to power what? Minus 1 in this case. 10 raised to power minus 1 in this case. So we have, excuse me please, we have 8.0 over 1.6 times 10 raised to power minus 1. 10 raised to power minus, which is what? 0.1. Right? That's 0.1. So we have 8 times 0.1 is equal to 0.8 over 1.6. So 0.8 here 1, 0.8 here 2. So we have sine theta is equals to what? 1 over 2. Then theta is now equals to sine inverse of 1 over 2. And sine inverse of 1 over 2 is what? 30 degrees. So you have to know your special angles. You have to know your special angles. So you will be going to your calculators, and JAMB calculators are, I don't know the term I can use for JAMB calculators. It's very, very slow. So you have to know your special angles at least. Sine 30, which is equals to cos 60. Cos 30 is equals to sine 60. So you have to know those relationships. And you know your sine 45 is equals to what? Cos 45, which is what's it called? 2 over 2. And sine 45 is also what? 2 over 2. And that's all. You have to know your special angles. Your tan 45, which is equals to 1. Sine 90, which is equals to 1. And cos 90, which is equals to 0. So you have to know your special angles. So sine inverse of 1 over 2 is what? 30 degrees. So the correct answer to this is C, 30 degrees. On 34, the number of neutrons contained in the nucleus of uranium. Now, this 234 that is up here, it is the mass number. Why the 92 is the what? Atomic number. Now, let's go back to our foundation. We said mass number is what? Is the sum of our proton and neutron. Why the atomic number is the what? Is the number of proton in an element. Now, look at this. I said mass number is equals to number of proton and plus number of neutron. So we have the number of neutron there, which is the atomic number. The atomic number here is the base number you are seeing here. Why the one here? That is the one at the as the power side. Let me use that time. Power side is 238 is the what? Mass number. Now we now have mass number is what? 238, and the number of proton, which is what? The atomic number is what? 92. So plus, let's say number of neutron. Let's use n as the number of neutrons. So if you want to get the number of neutron now, that will be n is equals to 238. That is your minus your 92, because the equals to sign to change to what? Negative 92. So minus 92. So N equals to what? 238 minus 92, and that is what? 146. That is the number of neutron. 146. That is the number of neutron present in the nucleus of 292. Mass number of uranium 92, and mass number the atomic number of uranium is 92, and the mass number is 238. Then how do you get the what? The number of neutron. The number of neutron, you can get the number of neutron. If you look at the mass number, when we add number of proton and number of neutron together, it gives us the mass number. So you just have to subtract it from what? Number of proton. Subtract the number of proton from the what? Mass number. And how do you get number of proton? It is the atomic number. Usually at the what? At the base level. Do you get me now? So that's how you solve questions. So question 35 now. Question 35. If the threshold frequency for tungsten is 1.3 times 10 raised to the power 5 Hertz, what is the work function? A, 8.58 times 10 raised to the power minus 19 joules. B, 8.60 times 10 raised to the power 15 joules. C, 5.0 times 10 raised to the power 19 joules. D, 8.58 times 10 raised to the power minus 10 joules. Now, look at this. If you want to solve a question like this, all you have to do is look for the relationship between your what? Your work function, your what? And the frequency. Now, if you can remember, from our SS3 days, we have work function is equals to what? Planck constant times what? Frequency. Times what? Threshold frequency. And how do we get our work function? Work function is equals to product of frequency, threshold frequency times what? Planck constant. And Planck constant is what? H is equals to what? 6.63 times 10 raised to the power minus 34. That is our Planck constant. So we have to put work function is equals to 6.63 times 10 raised to the power minus 34 times what's our frequency? 1.3 times 10 raised to the power 5 Hertz. 1.3 times 10 raised to the power 5 Hertz. Now, if you multiply this, it should give you 8.58 times 10 raised to the power minus 29 joules. So that is option A. 8.58 times 10 raised to the power minus 29 volts. So that is the correct answer. Question 36. The primary coil of a transformer has N turns and is connected to a 120 volt AC power line. If the secondary coil has 1000 turns and a terminal voltage of 120 volts, that means you are asked to look for this N, number of turns. Are you getting now? Number of turns that the primary coil has. So let's look at this N turns. So now, in order to do this, if you can remember our transformer formula, that one that deals with electromotive force, number of turns and current. The one that deals with electromotive force, number of turns and current. So this is the formula. We have NS over NP is equals to ES over EP, which is equals to IP over IS. Now this is just to tell us that what the number of turns in secondary cell, in secondary transformer, is actually greater than the number of what's it called, turns in what? Primary. I get it now. In primary transformer, you know you have your secondary and your primary transformer. So the number of turns you have in your secondary transformer is greater than the number of turns. So definitely, if there is an increase in number of turns, I get it now, there will be an increase in what? Electromotive force, and a decrease in current. If there is an increase in number of what? Turns, there will be a what? An increase in electromotive force and a decrease in number of current. So if there is a decrease in number of turns, there will be a decrease in electromotive force and an increase in number of current. So you have to know that fact. Now, let's solve this. We are not given anything related to what's it called? Current there. So we have to use NS over NP is equals to ES over EP. That is electromotive force is in voltage. So than what we have to do here. So the number of turns in primary we're not given. Primary coil of a transformer has n turns, so we're not given. So we have to look for that. So we can make NP the subject of formula is equals NSEP divided by ES. So NP is equals to what? NS, that is number of turns in second, which is what? 1000 times our EP, which is the electromotive force in our primary transformer, which is what? 120 over ES, which is what? Electromotive force in our secondary cell, which is 1200. So yeah, 0 will cancel 0, 0 will cancel 0, 12 here 1, 12 here 1. So the number of turns is what? 100 tons. 100 tons. So that is the right answer to this 100 tons. Question 37. The capacitive reactance of an AC circuit that contains a capacitor of capacitance 10 microfarad and operating at a frequency of 50 Hz is A. 2000 ohms, B. 500 ohms, C. 200 ohms, D. 318 ohms. That's to tell us that the SI unit of capacitive reactance is what? Is ohms. So now the formula for capacitive reactance is 1 over 2 pi FC. Are you getting it? When it comes to capacitive reactance, we have inductive reactance. That's when you're having XL equals to 2 pi FL. This is for inductive reactance, and this one is in M. Are you getting it now? Is in M. So let's look at this. XC, which is for our capacitive reactance, is equals to 1 over 2 pi times our frequency 50. Right, from the question it is 50, and what's our capacitance? It is 10 microfarad. So multiply 10 times 10 raised to power minus 6 farad. Now it's not in farad. That is, look at this is in microfarad, and micro is 10 raised to power minus 6. So whatever we have there, multiply by 10 raised to power minus 6, or divide by 10 raised to 0. Any way you want to put it. So, but initially, if you have microfarad, this is actually multiplied by 10 raised to power minus 3. If it's pico, it is 10 raised to power minus 12. If it is nano, that's 10 raised to power minus 9. In case if you are not seeing microfarad, it is nanofarad, it is 10 raised to power minus 9. Pico, 10 raised to power minus 12. So in this case, SC is equals to 1 over 2 pi times 50 times 10 times 10 raised to power minus 6. So by the time you multiply this, your pi is 3.142. So or you say 22 over 7. Any one you want to use, that use 22 over 7, or you use 3.142. So 2 times 3.142 times 50 times 10. Now this is some scientific calculator. Some kind of scientific calculators. I would advise you to use exponential. So that exponential is times 10 raised to power. That is the work of the exponential. EXP at the base of your calculator, you see EXP there. That is the work of the exponential. You see times 10 raised to power. So you just write 2 times pi times 50 times 10 exponential minus 6. Then you arrive at 318.30 ohms. That is the answer is D. 318 ohms. That is 2 pi. It is 2 times 22 over 7 times 50 times 10 times 10 raised to power minus 6. So if you do that using your calculator, you arrive at 318.30 ohms, approximately 318. Question 38. A man hears his echo from a nearby E 2 seconds after he shouted. If the frequency of his voice is 260 Hz and the wavelength is 1.2 meters, how far is the hill? That is the distance. Now, when it comes to echo, velocity of sound, we have V is equals to 2D over T. To calculate what velocity of sounds, That is this. Here is the distance, and this is the time. So v, how do you get v from wave? It said v is equals to what? Lambda times frequency. Lambda times frequency. Now in this case, let's look at our wavelength and our frequency. Now we have a nearby u. You have a t to be 2 seconds, and he shouted if the frequency of his voice is 260 hertz, that is f is equals to 260 hertz, and the wavelength is 1.2 meter, that is lambda is equals to what? 1.29 meter. So v is equals to 260 times 1.29. So velocity is equals to 260 times 1.29. So that's 335.4 meter per second. That is the velocity of the sound in this scenario. Now, using this formula to calculate the distance, that is, how far is the hill? Now we want to calculate the distance of the hill from the man. I get him now. So we want to calculate the distance of the hill from the man. Now we have v is equals to 2d over t. Then we'll make d the subject of formula from here. We have vt is equals to what? 2d. Then d is equals to what? D is equals to what? Vt over 2. So in this case, d, which is the distance of the hill, will be velocity 335.4 times the time, which is 2 seconds, over 2. So 2 we cancel 2. We have the distance to be what? 335.4 meters. That is the distance of the man, of the hill from the man. The answer to this is option D. That is 335.4 meters. That's the distance of the man from the hill. Question 39. All images formed by convex mirror are always dash, dash, and dash, irrespective of the position of the objects. In this question, I will ask to look for the nature of the images formed by a convex mirror. And you know your convex mirror is a diverging mirror, while your concave mirror is a what? Converging mirror. The reverse is lens. It's lens that concave is what? Diverging, while your convex is converging. But convex mirror is a diverging mirror, while your concave mirror is a converging mirror. Now, irrespective of the position of your objects. Now, you know, when it comes to a concave mirror, at the center of curvature and principal focus, it is always magnified, erect, and low. You guys can know that if you want to. So, at the center of, in between your center of curvature and the pole, center of curvature and the pole, it is always magnified, erect, and real. But when it's at center of curvature, it's always same size as the image. That means the what's it called? The image form is same size as the object at the center of curvature. Now, but in convex mirror now, irrespective of the position of the object, irrespective the position of the object, it is always diminished. Diminished means reduction in size. It won't be the actual size. Now, erect, another name for erect, upright. And virtual. Now, virtual images means virtual images cannot be formed on a screen. Those are images that can't be formed on a screen, and they are formed behind. They are not formed at the front. Real images are formed at the front of the screen, while your virtual are formed behind the screen. And now, virtual, how do you know it is virtual? Mostly images, maybe image distance, I get you now, your V will be having a negative sign. I did that earlier. To having a negative sign, that's how you know, okay, this is virtual. If it's positive, you know it is what? It is real. So it is always diminished, that is, there will be a reduction in size. Erect, that is upright, it will be what? Inverted. And we have what? Virtual. Virtual means it's formed behind the mirror. I get it now. It is formed behind mirror. Virtual means virtual images can't be formed on a screen. Now, question 40. Convert 20 degrees Celsius to Fahrenheit. Convert 20 degrees Celsius to Fahrenheit. Now, this is the formula. You have F minus 32 over 9 equals to degree Celsius, this is degree Fahrenheit, over 5. Now let me just explain how they got this 32, all this 9 and 5 to you guys. Initially, if you look at your temperature scale, so Celsius scale and the Fahrenheit scale, you have, now let's say this is our steam point here. For Fahrenheit here, we have the steam point is 212, while the what's it called? The ice point is 32. Now, for our Celsius scale, steam point is 100, and here it is 0 degrees Celsius for ice point. Now, what we have to do here is, now look at this, F minus 32. This 32 now is what? Our ice point in Fahrenheit. That I have F minus 32. Now we now have, this initially was not 9, it was 180. Which is the distance. That is distance from what? Ice point and the steam point. That is 212 minus 32 give us 180. And here we are having 100 initially. So if you divide, 0 will cancel 0. 5 here, sorry, 2 here 5, and 2 here 9. So that I got F minus 32 over 9 is equals to degrees Celsius over 5. So our Fahrenheit, our question in Fahrenheit was what? We are asked to convert to Fahrenheit, but we are given degrees Celsius. So F minus 32 over 9 equals to 20 over 5. And 20 over 5 is what? 4. So we now have F minus 32 over 9 equals to what? 4. Then from here you cross multiply. So F minus 32 is equals to 9 times 4. So F minus 32 is equals to 36. So F collect like terms, 36, our negative cosine equals to change the thing towards positive minus plus 32. So we now have F equals to what? 68 degree Fahrenheit. So whenever you have to convert from degree Fahrenheit to degree Celsius or degree Celsius to degree Fahrenheit, you make use of this formula. And whenever you want to calculate or you want to convert degree Celsius to Kelvin, you always add 273. If you want to convert Kelvin to degree Celsius, you subtract 273.
So this will be the end of this particular video for the 40 likely JAMB physics questions. If you've been enjoying this video so far, don't forget to like, comment if you have any questions, and subscribe to this YouTube channel, because that is the best way to support this YouTube channel. If you have not subscribed, I don't know what you are waiting for. Don't forget to join the MathChem community by subscribing to our YouTube channel, right? If you want us to make the chemistry version of this video, I'll be making it myself. So let me know in the comments. I'll see you guys in the next one. Bye guys.